Alright, so we're going to use the division property of radicals to simplify radicals as well. Here's our division property of radicals. It says that if we've got some square root of or nth root of a over b, we can rewrite it as square root of or nth root of a over square root or nth root of b, whatever that n index is. But we can also, instead of kind of separating and conquering, we can combine and conquer. So that's the topic today, is combine and conquer. So if I've got something like cube root of 9 over cube root of 72, cube root of 9, I can see cube roots, perfect cubes would be 1 cubed is 1, doesn't help us. 2 cubed is 8. We can't rewrite 9 as 8 times something, so maybe we can combine these guys to say, well, let's see, I'm looking for a cube root of 9 over 72. I'm looking for a cube root of 9 over 72 is 1 over 8. Now that looks a little bit better. I could say this is cube root of 1 over cube root of 8. Cube root of 1 is 1, cube root of 8, because now we can separate from here to here. We can separate and conquer. Cube root of 8 is 2. Done. So we can separate and conquer, or we can, for this one, combine and conquer. Same thing here. Square root of 7, that can't be simplified. Square root of y squared, or sorry, y cubed could be simplified, but maybe we can look to combine these first and say it would be one giant house of 7y cubed over y. Simplify the y cubed over y, and that gives me a square root of 7y squared. Everything's inside the house. Equals square root 7 square root y squared equals square root 7 square root of y squared, y. And we could make it prettier by saying it's y square root 7. Usually the things that are outside the house are written first. That would be the prettiest, most elegant looking answer for us. Alright, so the same ideas hold true down here. Maybe try to pause the video and see if you can get these answers first before we work through them. Alright, let's see. Cube root of 250? No, can't do it. Probably cannot rewrite it, but I'm going to, you know what, as long as it's cube root over a cube root, I'm going to rewrite cube root over, of 250 over 2 is cube root of 125 by pulling out the calculator. Cube root of 125 is, well, it's 5. Because it's actually, well, let's go the long way. Cube root of 125 is cube root of 5 cubed. Cube root of a perfect cube means the base comes outside the house as 5, and there's our 5. Alright, let's go over here and take a look at this one. I got a square root and square root. Square root and square root. Let's see, can I take the square root of 10, simplify that? Nope. But I could maybe simplify this way. Square root of 10 z to the 9th power over z. Alright, this is square root of 10 z to the 9th over z is z to the 9 minus 1 is z to the 8th power. Alright, simplify anything there? Well, it's square root of 10 comes outside the house. Square root of z to the 8 gets its own house. Yeah, let's go with columns. I got square root 10. 10 cannot be rewritten as a perfect square times something else, so square root of 10 is square root of 10. This can be rewritten as z to the 4th power squared. That's a 2. This is a 2 compared to the z. Square root of 10 is still square root of 10. I've got square root of a perfect square means the base comes outside the house. I got a z to the 4th power. And that's made elegant by putting the things that are outside the house in the front yard, or the coefficients should be the things that are outside the square root. Z to the 4th square root of 10 is a good answer. Alright, let's see, let's tackle this one in a separate video.